side. I hope the acoustics are all right. I would like to welcome everyone who had the chance to dial in to today's webinar. My name is Corinna Jörling and I work for Navigant on energy policies and the transport sector. I would also like to thank the Energy Innovation Academy for the opportunity to present some of our findings from this project on the transport sector. And I will speak for about 35 to 40 minutes, and then I'm happy to take any questions after that. So let's have a quick look at today's agenda. I will aim to give you some context on the Beacon project to let you know why we did these analyses. And I will then talk about the trends and challenges that we see in the transport sector on the European level before I go into detail on the two instruments that we will focus on today, which Fernando has already announced, that are the incentives for e-mobility in Norway and the bonus-malus scheme in France. Now, we have conducted the analysis of national climate policy instruments in the context of the Beacon project. This is funded by the German Ministry for the Environment, Nature Conservation and Nuclear Safety, and it is part of the funding program of the ministry called the European Climate Initiative. It's also known as EUCI, and this is coordinated by the German Society for International Cooperation. Now, the project background is the effort-sharing decision and the effort-sharing regulation, which requires EU member states to significantly reduce their CO2 emissions. And Germany is not, with all their targets, on track. It will likely miss its effort-sharing decision target for 2020. And this is part of the reason why the Beacon project was launched. Or the EUCI initiative has quite significant funding as well. Now, the project goal is to really strengthen the bilateral and multilateral cooperation between member states and create common ambition to realize the Paris Agreement. The duration of the project is 3 years, so it started last April and will last until March 2021. And what's special about the project is that it really has a multi-governance approach, which means that it aims to link the national and municipal dimensions of climate policy and even aims to carry the knowledge and the awareness of climate change into schools. So we have an analysis of national climate policy instruments. We foster the exchange with municipalities directly and also have trainings and events in schools in different European member states. And all of these activities are supported by knowledge management and communication activities, which are led by Navigant. The project is implemented by Navigant as the project leader, as well as Adelphi and the Independent Institute for Environmental Issues, the UFU. You can see the project partners on the bottom right of the slide. And these three organizations are supported by 8 other organizations. So we have quite a huge consortium of 11 partner organizations implementing this rather large project together. And I would like to give you an impression of the geographic scope. So the project covers Eastern and Southern European member states. This includes Portugal, Poland, the Czech Republic, Romania, Bulgaria, and Greece. And you can see on the slide how we have found municipalities and schools in these different member states. And what we do with them, with the schools, we have trainings, capacity building, and event days in the schools. With the municipalities, we also have trainings, we have a big conference, and a number of different activities that really try to help foster the exchange of climate policy instruments that have worked, and also work on an exchange of lessons learned as well. Now, the projects or the policy instruments that I will be talking about today were analyzed as part of the work package on the national climate policies. We have drafted overall 22 fact sheets. This includes analyses of national climate policy instruments and also some national climate framework policies, as well as an overview paper. And we've done this for 4 different sectors. That's the transport sector, the building sector, the industry sector and the agricultural sector, so all sectors outside of the ETS regime we have covered. And the key question really was, what are the sector-specific policy instruments in other EU member states, including Switzerland and Norway, from which Germany can learn to improve its climate policy? However, we really found that a lot of the findings are also applicable to other European member states, so this should not be limited to the German context at all, which is also why we thought it would make sense to address the results to a wider European audience, so I'm happy to have this opportunity today. The selection of the instruments was dependent on whether the instruments would be relevant for the German context and also be applicable to other member states. So we looked at to what extent the learnings could be taken to other national contexts and applied there. We analyzed sector-specific data for this and then looked at which countries were good performers in the different sectors and then tried to analyze which instruments were in place in these states and why they were successful. This is how we came to the selection that you can see here. And these are the two instruments that we will be focusing on today. That's France and Norway on the very top of that table. Okay, let's dive into the transport sector, the trends and the challenges that we see on the European level. Now, more than a third of the EU-wide effort-sharing decision emissions come from the transport sector. I think this really is a call to action that is quite significant, and it shows that without significant reductions of greenhouse gas emissions, the European Union will really struggle to reach the Paris climate goals. And this works. Okay. So I would like to look at a few key indicators to understand the transport sector a little bit more, which will allow us to also tackle the challenges that this sector poses. First of all, the graph on the right shows that 97% of the sector emissions are from road transport. The pie chart shows the sector emissions from fuel combustion, and it shows that the 79% are from road transport and the rest is covered by railway transport, inland waterway transport and other transport systems. So if we want to reduce sector emissions, then road transport really is the way to go forward, and I think this is also reflected very strongly in the discussions that we have in the transport sector, that we do have discussions on the railway sector and on the inland waterway transport to some extent, but we really need to focus on road transport, and that includes passenger and freight transport as well. Now, the share of electric vehicles in 2007 was at 0.3%. That is the share of the total fleet, not the new market registrations. And this is, of course, to be expected, but it's still really, really low. It is in the center of a very intense discussion, but what we see on the market is still very, very marginal. For biofuels, we have a slightly higher percentage of the biofuels in the total fuel mix. It's at about, in 2015 it was at 6.7%, and this is foreseen to increase quite a bit. By 2020, it's foreseen to increase, and we will see whether these targets can be achieved, but we also see that at the moment it's still rather low. The development of the transport sector emissions has shown that the absolute emissions have sunk between 2005 and 2015, 2005 being the reference year for the effort sharing decision, and it has sunk by about 6% overall. Before 2017, emissions had been increasing. We then saw a dip of EU-wide transport sector emissions after 2017 until 2013, and since 2013, emissions have increased again. On the chart on the right, we have a couple of examples. So we see for the European Union as a whole, we see the emission reduction between 2005 and 2015. And while for Germany, the emissions were constant since then. And we see that France, the Netherlands, Sweden, and Switzerland were able to reduce their emissions. The Netherlands and Sweden quite significantly by over 10%. Norway did see a slight increase. We still decided to focus on Norway as one of the target countries for the policy analyses because emissions have sunk rather quickly since 2015. The emission intensity of the passenger kilometers traveled could also be reduced by 9% since 2005. And the energy intensity, the intensity of energy consumption in transport was reduced by 3% EU-wide. So these are relatively positive messages, but we see that in general, the increases in efficiency that could be achieved in terms of the fuel efficiency and the vehicle efficiency have not been able to offset the increasing demand for transport that we've seen, so the transport performance. Because both the passenger transport and the freight transport is still increasing in terms of the volumes, we haven't seen significant reductions of the transport sector emissions. Now I would like to go into detail on the first policy instrument, which is the policy mix that Norway has put in place to incentivize the purchase of electric vehicles. As I've just said, the policy instrument that Norway has put in place is really not a single instrument, but it's rather a mix of a whole set of different policies to incentivize the purchase of electric vehicles. And this has been really broad. It has also been going on for quite a long time. We saw the first instruments introduced in 1994 and have since seen that Norway has continuously introduced further instruments over the years and also adjusted the instruments that were in place continuously. So they have really been constantly adjusted, they have been updated, and in some cases even abolished. We have a combination of financial and non-financial instruments. In Norway, I will go into detail in a little bit into what exactly is in place here. Overall, Norway aims to achieve a target in 2020 of 85 grams CO2 equivalents per person kilometer, which is of course very ambitious if we look at the European Union target of 95 grams of CO2 equivalent per person kilometer. And this already shows how ambitious Norway tackles the transport sector here. Okay, let's go into further detail. This table shows you an overview of both the financial and the non-financial incentives that Norway has put into place. For the financial ones, there is an exemption from the registration tax, from the value-added tax on leasing and on vehicle purchase. This is very, very important because the VAT is very high in Norway with 25%, and the exemption means that the total cost of ownership really goes down by quite a significant amount because of this exemption. We also have a reduction of the company car tax and the annual road tax, which is in place for electric vehicle owners. There is an exemption from tolls and from ferry rates as well, and there is free public parking in some cities. So this depends a little bit on the municipality that the electric vehicle owner is located in. And these financial incentives are then complemented by non-financial incentives. This includes the handout of a special license plate and also the right to use bus lanes. I'm sure many of you have heard, at least in part, about the discussions that have been going on. It has been quite a famous example of a non-financial incentive for the electric vehicle owners to use the bus lanes. And I will go a little bit further into detail about the challenges that this has also posed in a little while. And what's really crucial here is that the total cost of ownership for electric vehicles has gone below the total cost of ownership for traditional vehicles. And this is something that other countries that have also introduced financial incentives for electric vehicles have not been able to achieve. So as an example, on the bottom of this slide, if you see the vehicle price for the end customer, this is just the purchase price, by the way. For a traditional Volkswagen Golf, the price is at approximately 31,000 euros, while for the electric Golf, we're looking at 27,000 euros. So the end customer is really faced with a decision to pay more for a traditional vehicle. This is similar for the higher priced category. So for example, an Audi R7 would be at approximately 73,000 euros, whereas the Model S Tesla would be at 67,000 euros. So we also see a difference in the higher pricing segment. There has been a discussion to abandon the incentives for the highly priced models because there was some rejection of subsidizing these already very pricey vehicles for owners who would be from a very strong socioeconomic background. This discussion had been going on for quite a while, but it has now been abandoned. So the financial vehicles continue to be, financial incentives, they continue to be in place, meaning that the total cost of ownership remains lower for electric vehicles or for comparable category. One more point on this. There has been a study in 2017 on the rating to ask the electric vehicle owners which of these instruments they have perceived to be most important, because there is such a wide policy range, of course, and they have said that, let me just use this one, that the exemption from the value-added tax, the road tax, and also the registration tax were the three incentives that were most important to them. So the non-financial incentives, they do have value for the customers, but really the most important ones were those that subsidize the purchase and the ownership of electric vehicles. So when we talk about the impacts of this, let me first say that Norway really is an absolute front runner when it comes to electric mobility. There is no other country in the world that has achieved market shares that are as significant and as large as Norway has achieved them. In 2017, there was a market share, and this is the share of new registration of vehicles, of battery electric vehicles and plug-in hybrid electric vehicles of 39%. You can see this on the graph on the right, how there has been quite a dramatic rise and a quick increase of the share of these vehicles. We have compared this here with the German context just to give you a comparison, where we see that the share in Germany of new registrations is really, it's far below 5% still. And this is similar if you look at the entire European Union. And even at other more successful examples like California, for example, we don't see anything that's in the same range, I would say. And when we look at the total fleet share, so this is the stock of all vehicles that are in a country, in 2017 Norway had about 5% of battery electric vehicles and plug-in hybrid electric vehicles. One thing that's important to note is the distinction between the battery electric vehicles and plug-in hybrid electric vehicles. Some of the financial incentives, they differentiate between a battery electric and plug-in hybrid electric vehicle. However, most of the incentives are in place for both, or have at least been in place for both for quite a while, and this has been changed now. So there is a consciousness that, of course, plug-in hybrid electric vehicles don't have the same potential to save CO2 emissions as fully battery electric vehicles do, but at this point, plug-in hybrid electric vehicles are also still incentivized. As I said in the beginning, Norway has seen a quick fall in emissions from the transport sector between 2015 2016 by 3.6%, which is quite significant for a year for a sector reduction. And it has reached its target for 2020, which I mentioned a couple of slides ago, of having an average 85 grams CO2 equivalent per person kilometers for new vehicles in 2017 already. So comparing this to the current average in 2017 in the European Union of 118.4 grams, this really shows how well this has worked and how much Norway has already lowered its emissions per vehicle kilometer. So very impressive results here. So let's go into the success factors and the challenges that the instruments and the policy mix has seen. Let me check this. Okay. So first of all, the policy instruments have been embedded in a national strategy. Norway is very ambitious when it comes to climate protection as an overarching scheme, and the targets for the transport sector and for the electric vehicles in particular have been cross-checked with the national strategy repeatedly. Norway has also benefited from a wide political consensus on these policy instruments, and also a rather high public acceptance of the subsidies and of the non-financial instruments as well. Norway has a very high GDP, which of course helps to finance the subsidies. Given that they are very, very significant, this may not be possible in every national context to have such high financial subsidies for vehicle ownership. However, in Norway, given the really high GDP, this has been an enabler to allow the continued high subsidies for electric vehicles. We also see in the building structure of Norway a rather high share of single and two-family houses, which means that the owners can charge at home. And this is, of course, a very convenient factor and means that the vehicle owners always have the guarantee of being able to charge at home at any time and are not dependent on public charging infrastructure as much as this would be the case in a national context that has a higher share of multi-family homes, where it's not possible to install an individual charger for every vehicle. Norway already has a really high share of renewable energy in the electricity mix, which allows for a high emission reduction potential. Of course, the savings that can be achieved by the uptake of electric mobility, they depend on the emission intensity of the national electricity mix. And this helps, of course, also in the political argumentation about these sorts of instruments if you have a very high emission reduction potential. Another factor which is not quite as dominant in the discussion at the moment is that Norway has a high distribution grid capacity, which is due to electric heating being very common in Norway, and this makes the grid extension costs less relevant. So this means that the capacity installed in individual houses in Norway is higher than, for example, in the German context. As an example, in Norway, the average household electricity consumption is at around 16,000 kilowatt hours per year, while in the German context, the average consumption is substantially less, with around 3,500 kilowatt hours per household. And this means that the grid is also able to support much higher loads in the individual households, and this is something that, especially in the medium to long term, really helps to support the market uptake. We can see in the German and also increasingly so in the European discussion on the uptake of electric mobility that the factor of whether or not the distribution grids will be able to support very high shares of electric mobility becomes increasingly important. And so Norway already having a relatively high grid capacity of the distribution grid helped the country to support the high shares, and will also be a very important factor in the future when the market share of the total stock goes beyond 5%. There has also been a reduction of the local air and noise pollution, This has already been recorded, but it's also been an important argument in the political discussion that there are quite some significant co-benefits, of course, which I think everyone would be familiar with here. Now, when we go into the challenges of this incentive mix, I think the high total cost for the state and also for the municipalities really are at the center of the discussion because, as I said before, a minimum, like a significantly high GDP is necessary to support this, and also the municipalities need to be able to support the instruments that they need to finance themselves. The municipalities have in particular been in charge of installing charging infrastructure, and this of course puts a strain on the municipal budgets, and because of the high the high total costs, the instruments have also been under discussion in the Norwegian context on the national level, of course. And this is something that will always be at the center of whether or not such ambitious financial incentives are introduced. There has been quite a lot of media attention on the traffic congestion on bus lanes. As we noticed a couple of slides ago, there is the possibility for electric vehicle owners to drive on bus lanes. This has led in some municipalities to congestion on the bus lanes, which means, of course, that the public transport suffers from the incentives indirectly. And this has meant that some municipalities, Oslo and Bergen, for example, have put restrictions on this, including, for example, the obligation for electric vehicle owners to, or the allowance to use the bus lanes only if more than one passenger is driving in the car, which has then led to very absurd effects of some people reportedly using puppets or fake persons on the driver's seat to get through the controls. Not all of this has been confirmed, but of course, in general, this is a challenge, and the fear of congesting bus lanes has also been an argument that has been quite prominent for municipalities in general, who are very anxious of this problem. We also see currently that the public charging infrastructure in cities and municipalities presents a challenge. We see that in Oslo and in Bergen as well, to the point where last year the Electric Vehicle Association Norsk Elbilforening had recommended to stall the purchase of electric vehicles if individual potential customers, so citizens, are not located in single or double family houses, because the public charging infrastructure was not anymore able to keep track with a quick market uptake. So the right timing of market uptake and infrastructure uptake also needs to be considered here. And there is a general argument that is sort of against incentivizing electric vehicle use in such a large manner, which is that motorized individual transport should in general not be so incentivized, and that support measures should rather focus on public transport and on cycling. So that would mean, for example, the building further bike tracks and improving public transport. But this is, of course, a very general debate and will always come up in this context. Okay. Let's see. So this has been the discussion of the Norwegian incentives for e-mobility. And I would now like to go into our next example, which is France. This also covers road transport, just as the last instrument. And France had introduced this scheme already in 2008. The bonus-malus scheme is the label. I should probably mention that. And the initial target that was set in 2007 was to reduce the average CO2 emissions per kilometer from 149 grams of CO2 per kilometer in 2017 to 130 grams of CO2 per kilometer in 2020. This shows, of course, that this was a very premature target setting. We now have the target of an average 95 grams of CO2 per kilometer in place in the European Union, which also applies to the French context, of course. So this old target has been overridden, But this is the first important aspect, that the target of the instrument can be adjusted over time, of course. The instrument in general targets the customer at the point of its purchasing decision. So it's mostly an instrument aiming at this decision moment, because it does not carry through into the total lifespan of vehicle ownership. It only sets an incentive at the very initial point. And the instrument, as I just hinted at, has been adjusted multiple times since it was first introduced in 2008. The functioning of the instrument is as follows. So the customer of either purchased or leased vehicles, they pay either a fee, which is the malus, or they receive a bonus at the point of registration of the vehicle. And these fees or bonuses depend on the vehicle's CO2 emissions. So a vehicle that emits below 20 grams of CO2 per kilometer will receive a grant of 6,000 euros, whereas for vehicles that are at the threshold of 120 grams per kilometer, 20 grams of CO2 per kilometer pay a very small fee, or a malus of 50 euros. And then as vehicle emissions per kilometer increase, the malus payments also increase. The threshold, which is also shown in the graph on the right, means the point at which the bonus payments switch to the malus payment. So wherever a national government, or the French government in this context, sets the threshold is where it's going to change from a malus to a bonus. And we see here on the list on the left that the payments are really quite significant when it comes to very high emission vehicles. So 185 grams with a malus of 10,500 euros is really quite significant, and something that can really influence a purchasing decision. And what's central for the design of the instrument is that the malus payments refinance the bonus payments. So whatever the state gains in terms of malus payments is collected in a fund and then refinances the bonus payments. The graph on the right shows both the threshold and also how this has developed over the years. So in 2017, that's the darker black-purple line, the threshold was at 120 grams. It has been lower in the past, which shows the blue line from 2008 to 2009. And also in 2017, a linear increase of malus payments in correlation with the vehicle emissions has been introduced. This had been a stepwise approach before then, and has now been made linear. And then at a certain point, this is the 185 grams of CO2 emissions per kilometer, the payments level off, so that would be the 10,500. This is sort of the maximum that has to be paid. What's important when we talk about the applicability of the instrument in other national contexts is, of course, that these two lines, the two graphs that we see on the right, are really subject to the national decision. So they can be calibrated however the target should be set. It is very flexible in this respect. So when we go into the impact, first of all, looking at the main indicator, in 2017 we had in France average emissions for new registration of 111 grams of CO2 emissions per kilometer. When we think back to in 2017, that was still at 149 grams of CO2 per emission per kilometer. So there's been quite a reduction. And of course, it remains to be seen, hence the lighter purple arrow, whether the target for 2020 of 95 grams of CO2 emissions per kilometer can be reached with the help of this instrument. When we look at the graph on the right, we see that the sales distribution has changed. It has shifted from the bluish 2008 sales distribution to the 2016 purple sales distribution. And this is in dependence on so the y-axis here are the CO2 emission, the gram CO2 emissions per kilometer. So we see that there's really been a shift from a sales distribution of more emission-intense vehicles to less emission-intense vehicles. And it cannot be said that the causal relation is not as straightforward, that this shift can only be attributed to the bonus-malus scheme, but it has certainly helped to incentivize this shift to a less emission-intense mix of vehicles. When we look at the emissions that have been able to, that could be saved because of the instrument, we have quite some methodological issues here, because it's very difficult to separate the savings that have been achieved by one instrument from the effects that have been achieved by other instruments. And because in the French transport sector there is a mix of instruments in place, it's not possible to determine exactly which kind of emission reductions can be attributed to the bonus-malus scheme. The French Ministry for the Environment, however, has estimated that the bonus-malus system in combination with the other instruments will save around 5.5 million tons of CO2 emissions until 2020. We had total emissions from private vehicles in 2015 of 66 million tons. So an annual savings of 5.5 million tons is significant, but it has to be admitted that this will of course not be enough to really reach the goals of the climate agreement. So it does contribute, having the bonus-malus scheme in place does contribute to saving emissions from the transport sector, but it will not be enough to cover all the emission reductions that are necessary. In addition to the estimation for 2020, the Ministry has also published estimations for 2025 of 8 million tons and 2030, 9.8 million tons. So still looking at the total sector emissions, this will not be enough. However, it really has to be stressed that these estimations also depend on the current calibration of the instrument. And because this is a flexible instrument, it would be possible in theory to change the instrument in a way that more ambitious targets can be reached with it. I want to stress this again. I think the real appeal of this instrument is its simple design. It is a very clear communication towards the end customer. It has a very straightforward refinancing system, and it's a very simple design, and it can be changed as well. By just shifting the threshold that we've addressed a couple of slides ago, you can really change the incentive for buying ever less emission-intense vehicles just by shifting the threshold. So that's quite an advantage of this instrument. It also has to be stressed that with the current calibration of the instrument, the state has made a surplus of revenue. So there have been a lot more malus payments paid by the customers than bonus payments that have been paid by the state. This means that at the current stage, the instrument has refinanced itself. This is, of course, for the budget, for the national budget, that's very advantageous. However, this is, of course, not the main target of the instrument to refinance itself, and this might hint towards the calibration not being strict enough at the moment. So either the payments, the malus payments not being high enough, or the bonus payments not being high enough, or the threshold not being calibrated at the right point. We, in general, have a polluter pays principle here, which relates to the first argument, that this is a very straightforward instrument. There has been, especially in the beginning when the instrument was introduced in 2017, a support from the French automobile industry. This has been, for the political implementation and the introduction of the instrument, this has been really important in the democratic context, of course. However, this has to be taken with a bit of caution as well, because the automobile industry is also targeted by this, of course, and is incentivized to really reduce emissions, and the automobile industry is, of course, not always the party most open to these kinds of instruments. The system can be designed to be cost neutral. As I've said before, this can be advantageous, but it should not be in the focus of the target setting of this instrument, because really the CO2 emission savings should, of course, be the main target. The automobile industry is incentivized by this to develop low-emission vehicles. Yes, this has been stressed before. So when we go into the challenges, I think it's become rather clear from the discussion of the instrument so far that it's quite a challenge to fine-tune the instrument. So finding the right balance between the bonus and the malus payment is really something that has to develop over time. This is at least what the French example is showing. In the initial phases of the instrument, there were a lot of purchases from customers. So the state had to pay more than it received from the bonus payments, from the malus payments, of course. And this has changed over time. So France has made quite some interesting experiences with this, and applying this to any other national context would also mean that the calibration would have to be reconsidered repeatedly. Something that's been criticized quite a bit for the bonus-malus scheme is that at this point the instrument does not consider particulate matter emissions, which of course then creates a relative incentive for diesel cars compared with petrol cars. The only indicator in terms of emissions that has been considered so far have been the CO2 emissions. This is also something that could be adjusted if the instrument was to be applied in a different national context, of course. So in principle, it would be possible to not only tie the bonus and the malus payments to CO2 emissions, but also at other indicators such as particulate matter emissions. Okay, I'm already at the end of my presentation. I'm really looking forward to taking your questions, and also feel free to get in touch with us, of course, after the presentation.